So, hello everyone. Welcome to this week's episode of ClueCon Weekly, sponsored by SignalWire. This week with us, we have Divya Gupta, Senior Solutions Architect at SAS in the Global IoT Initiative. Thank you for joining us today. It's a pleasure having you here.
Thank you, Lucas. And I'm very excited to be here as well. And thanks for introducing me. And looking forward for the today's call, today's
Discussion.
chat. Yes,
Yeah, well, we'll go where IoT takes us. it's
indeed, indeed. Yeah,
so
it's indeed like everywhere.
For the few people who don't know her, Divya is one of the foremost experts in IoT, especially on the edge and cloud side of things. She's been through a variety of roles, but she's now at SAS, and I'll let her introduce herself for a little because it's better.
All right, I will do that. So, hi everyone. I'm Senior Solutions Architect at SAS Global IoT Division, and my work primarily involves integration of SAS Event Stream Processing in clouds and also on on-premises platforms using the today's cutting-edge technologies like containerization and Kubernetes. So, in my day-to-day job, I'm providing architecture solutions to the customers to solve their business problems and also help them bring some innovative ideas, some new business propositions using the IoT. So we all know today we are living in very interesting times. We have data everywhere. We have devices that are talking to each other, communicating with us, and are also able to make decisions on behalf of humans. So and if you would see around you, every single entity, humans and non-humans, everybody is generating data today. And
Yeah,
this is not happening at a very slow speed, it's happening at a very high speed. And the way we are generating the data, we need to have technologies that can also process this data which is being generated so fast. So if we do not process it on time, and then this data will accumulate and or it will become obsolete and will be old to make any good decisions or to derive any valuable insights. So it is very important for us that as soon as we have this high volume, velocity, and variety of data coming to us, it becomes extremely important and necessary that we take all this data, put it into right use, and derive the valuable insights out of it. And this should be done in real time. Only then it makes actual sense of having generating this amount of data. And so in my work, I'm working on how the data needs to be processed and how it should be processed in real time, and it can happen both at the edge and at the cloud. So in my work, I have working with edge analytics, and I'm also working with cloud analytics. So there the data needs to be processed both at the edge and in the cloud. So some data is because there are for some use cases, it's important that the data is processed right at the edge, but then there are some data that needs to be transferred cloud because there is availability of other data and other historic data, I would say, that can be used to create to have more different type of processing and have derive more different insights from there. So there is a complete path from the edge to the cloud and also vice versa, so from cloud to the edge. So you need to communicate with the device so that they can take the action on behalf of the humans. So yeah, so mostly I do this in my day-to-day job and working with the customers, but I also bring about like 11 years of experience in cloud computing area and distributed systems, fault tolerances, and have been working with a lot of customers, so engaging with business collaborations and consulting for them. And at the same time, I'm a hardcore technical person, so you can, for anything technical, I'm always up for that. And before that, I have a lot of experience with different R&Ds. I was working mostly in R&D and also with other consulting companies. And I did my PhD in France.
oh, nice.
So yeah,
Close to
it
where
was
I
in
live.
computer science. Sorry?
Close to where I live.
Oh yeah, yeah. It's you mentioned it's about like 100 kilometers from you.
Yeah, yeah,
Okay, yeah,
it's pretty close.
that's true.
Cool. Yeah. So a few things before we delve into what exactly is needed. As you said, you're an expert in the cloud and edge side of things. So,
Mhm.
but for the few people, I mean, not few, for the people who don't actually understand the definition of IoT, how would you
Uh-huh.
describe IoT for someone who's been, I don't know, a telephony engineer all their life, and now everything tries to talk with everything else, and nothing's
Yeah.
like it was.
So I would like explain IoT in simple words. It's called Internet of Things. That means each single device, for example, your phones, your coffee machine, your computers, everything is now is an electronic, but at the same time has sensors and can send signals from one device to another device. So when you are sending messages, when you are like using some application on your phones like accelerometer, then you are sending that data. So this is the data that you just generated. And just like that, if you talk about the sensors, different sensors that are there in some manufacturing unit, this is just to give you an example. So in a manufacturing units, for example, for pharmaceuticals, there are hundreds and millions of sensors at different places to measure the pressure, the temperature, humidity when the medicines are being in production. So they have to have the right temperature, the right humidity, the right amount of moisture in the environment, the right pressure when they make tablets. So all these sensors, finally they send the information back to us that this is what they are actually computing. And whenever there is a difference that you have to maintain, I would say 20 degrees Celsius, but then it varies. It goes 25 or 21. Even a slightest difference can give a signal and alert that the temperature has changed. So IoT I would define it as like all the entities when they are able to communicate with us, and then together, whatever the data that we are getting, we can find we can derive some insight out of it and take a better action, better decision, make a better decision. That's what I would say is IoT. Yeah.
Yeah,
And
that's a very good way to put it. So it's distributed devices doing some things to build a
yes.
bigger picture in a sense.
Yeah, it's important that we sense what are these devices, what data we need to get from them. And then it's also important that we understand that this is the data we are actually getting, and this is what we want to have. And most important is to act correctly, that we understand what the data is, we understand how to understand it, but now what? Now we need to take an action, the right action on this data that we have got. And this is where I see the value of IoT. This is how we derive the value of IoT.
Yeah, that's again, that's a very good way to put it. The cool. So IoT. Well, this brings into why the edge and cloud are so important in the IoT picture. Because what could come to mind to someone who's just starting out and learning about this is, well, if all this hardware now has uh, a brain on board, it will
Yeah.
do everything on its own, right? It doesn't need anything else. But that's not true, because from my understanding, am I playing with hardware, which is one of my favorite hobbies with my kids?
Yeah.
Those devices are very limited. They generally just do a couple things, if at all. Like it's not like your coffee maker is now
Yeah.
a Xeon CPU with 16 gigs of RAM. It will cost
Yes.
$1,000, but
Yes.
I mean, you could do that if you wanted to, but
Yeah.
it's pointless. So why is it so important to have first of all a strong edge, and I will say 5G plays into this, and then cloud infrastructure backing your IoT?
So, like as you said, all these devices cannot be that smart and cannot be that big that they can store everything there and can do all the processing right there. That's why we need the cloud. That's why we need a way that the data that is being generated can be sent somewhere else where the actual processing can happen. And that's why we need either on-premises platforms or cloud platforms to do that. And but there are when many edge devices that are capable of doing this as well. They have the capacity, they have the capabilities of doing that, and then they have to have a different use case altogether where they will be used and how they will be used. So for the small projects that you are doing at home, maybe you will not use high end devices that has all these capabilities. So you would just use some devices they are capable of sending the data to another place where you can perform the processing and then get back the results back to your the edge device. So this is one way of how it is done, and that's why it makes it important that we have both edge and the cloud analytics, because not every edge device today is capable of performing this processing. So we need to all have these capabilities. So we need to have uh, technologies both for the edge side and at the cloud side, and they all should be integrated well with each other. And also today we are seeing there are so many devices, edge devices. They all are different. They're running different. Maybe they kind of running the same protocols for communication, but the way they behave, the way they should generate the data, what they are capturing, how the sensors work, they all have different logics behind it. So it's also important that when we are dealing with how these edge devices should be onboarded to the cloud environment, to the cloud platform, that also needs to be taken care of. So it's very important that we go hand in hand with edge and I would say cloud or on-prem.
Yeah, how it looks like is that as a developer, I spend a lot of time working on prototypes, sort of research kind of role, and it feels like at the lowest point, the start is simply to get some logging out of your devices. But then, if you have a million small sensors,
Yeah.
how are you going to aggregate it without something that's a natural platform built for that? Like it's not simply going to be possible to find out which one of your 1,000 RFID tags in your warehouse is not responding correctly unless you have a way to analyze that for
That's so
sure.
true. That's so true. And you cannot handle this between edge to edge. You need to have a centralized place where you're getting information from everywhere, and then you know what's working, what's not working, which is failing, which is not failing, which needs to be maintained, which needs to be checked. This is all has to happen somewhere centralized, not between edge to edge. That otherwise it will be very complicated. And also you cannot manage so many millions of devices in your manufacturing unit or in any other place. You cannot do that. You have to have a proper system, a proper platform to do that as well, and to make the
It's
life easier. Yeah.
it's important to have everything should do what it's built to. So large
Yes.
computers and databases are for this kind of work. So why try and put your I've seen people try to put SQL databases on ESP32s so they could have some little embedded database in the device.
Yeah.
That
And
thing has Wi-Fi.
yeah.
Uh, so why don't
Yeah,
you?
that's also brings to an important thing that we need to have the right technology at the right place. If you just mess around putting a very bulky database into a small edge device, you're gonna fail there. And it's very important that you have the right connections and you have the right technology so that everything is smooth.
Do you feel like 5G and the edge computing it brings with itself? Because let's remember, 5G is actually well, it's a few things, but to the general public, 5G is better and more capillary connectivity across the world, plus the ability to put servers closer to your devices. It's a million other things. So the 5G people in the audience, please don't email me after. But it's, I know it's. But will you say that the two roles of better connectivity and being able to put computers closer to devices are helping?
Mm, to some extent, yes. And but like if you think about today, we have 5G, then there will be 6G. We always will have better connectivity and mobility there, and also putting the devices together closer to the network. That also helps because you actually improving on the latency there. So that ways it is positive response from them. So yeah.
Oh, so,
Yeah.
well, let's. I think something that helps people understand what we're discussing is a few real life examples. If you could bring some, like, what are more interesting IoT projects you've worked on that you're allowed to tell us about for sure? Because of
Sure,
course,
I
sometimes
can talk about a few use cases, customer use cases that I have worked with, and so from medical side, or it could be from manufacturing, predictive maintenances. So I can talk about the latest with the COVID related.
yeah,
So there in like
people
most of
can
the
relate with that for sure. So
exactly,
that's a good
exactly.
starting point.
Like that's the most because what we are doing is we want to maintain the distance between each other and not get contracted to the COVID. So this is something that has helped we always had asset tracking, but now we are tracking the humans, not to get too close to each other and get the COVID. So this is about contact tracing of people when they are moving in office facilities, or they are in a shopping complex, or in any, if they are working in some production companies, or if anywhere. It could, this is applicable for all the places where the people are working with each other, or there are people coming in and out every few minutes and seconds. So for example, if you have a facility, this was one of the use case. So people, as soon as they enter the building, everybody is tagged, they get a band, and these bands are able to send your location information, where you are right now at this particular time. So as you move, there are different gateways in the whole building, and these gateways are always connected to these devices that are in your with you. So as soon as you change the room, you change the floors, you change the areas in the buildings, they tell you where you exactly are currently, and this information is real time, sent to the to a processing a processing unit. So basically, I was using SAS Event Stream Processing, which all the data was sent there, and we were doing the risk analysis and trying to create the risk scores of all the people that are coming in close proximity to each other. So at any point when we see that if there is a person close to each other, then it became, if in future that particular person is infected, then we know what is the risk factor for the other people who came closer to this person. So that's how we were able to analyze and find out very quickly who should be the person who should be tested for the COVID. And that ways we were able to find out in very like in real time who must be, tested for the COVID. So this is one of the examples. And then there was an example for a manufacturing unit. So there are lots of this company was creating a lot of parts, and each part needs to be checked if they are correctly formed, if it is rightly in shape, in structure, and there were a lot of sensors that were detecting all that. So in this particular use case, we were also doing the real-time checks on each device when they were being manufactured, and at the same time we were also had the asset tracking in the manufacturing building. So asset tracking, I would say, is similar how we are doing the contact tracing for humans. So for asset tracking, each device was like had the tags, and we could find out where they are and in this particular moment in the whole place. So we can it helped in finding the devices, the assets faster, and not getting lost where they are. And so it was we could put these devices in use, and rather than them lying lost in somewhere in the warehouses. And this is another example from another hospital where there was about the assets tracking. And like you see in hospital, when you go, there are so many equipments everywhere. The nurses are dealing with all the equipments, the electronic equipments, the small equipments, like surgical things, and devices that are to monitor your heart, ventilators, this, that. There are so many different devices in the hospital. So here, sometimes what we have observed, that at any point of time, only 40% of the complete structure that the hospital has is being in use. The rest 60% is either lost or they don't know where it is.
Oh,
Yeah. So to maximize the use of the assets they already have, and not being just they put it there and then they forget where exactly it was, and then they're looking for that. So to manage this tracking of their own items, their own devices, it is helpful to put so this we have this tags for each device, and we know where exactly this device is. So whenever there's a need, so they can check in there, we have the application at the end, so you can check where exactly this device is, in which room it is located, where it moved, when it was moved there, for how many days it is lying there. And so it gives you all information. So again, it is based on the different gateways. So when you move these assets from one place to another, it sends a signal that, okay, it has been moved from here and it was in this particular place for so many days or so many, yeah, for such a long period. And then this is the final place where it is. So you can get that from there. So it is also for the asset tracking. I can go
Well,
on and on like that.
you mentioned another case which sounds really interesting in the wake of what has happened in various places, even in Italy where I live. Predictive maintenance. So
Yes.
in many cases, we've had catastrophes where people, I mean, people lost their
Yeah.
lives or just a lot of economical damage, if nothing else, where maintenance was not done properly. A few years ago, an entire bridge collapsed in Italy,
Mhm.
and after the fact they found out it had been 5 years since the cables had been checked and the concrete had been tested for erosion, that kind of stuff. So that's really
Okay.
interesting. It's so how does predictive maintenance with IoT work?
So how it works is that we are analyzing the performance of, for example, as you said, in your case, it would be the cables. So we will see what is the strength in there, if they're losing their strength. So there will be sensors monitoring their strength in the cables. And if they see that they're deviating from what they should have, and that means that there is some, it would tell us that there is something going wrong there and there needs to be either maintained or checked, or so because their strength needs to be what it has to hold the whole bridge. So this is how it goes, and it's mostly on the based on the sensors that are actually monitoring the strength there. So I mean, on the very layman language, this is how it would go.
Yeah, it is a so our yeah. There's a question you might or might, since you live on the other side, but I'm curious when they're putting sensors on things like bridges, etc. How are they powered? Is generally power ran through the system somehow? Do you have special batteries? I don't even know now that I think of it.
Some have that. Some have solar batteries, solar energy based batteries. Some have that needs to be replaced frequently. So there are different devices for different uses. And yeah, it is. And this is also another area where we also check what is the power of the battery and if it needs to be checked, so we can know that, okay, this particular in this particular device the power is going to run out very soon, so this needs to be changed, so we get an alert on that particular device as well. So all these is again IoT in IoT, kind of. So you also maintain these edge devices, their power, how they are performing, their capacities, and if they are doing their right job. So that also that data is also being generated there. Yeah, it's hard to this is one of the challenges with so many IoT devices and maintaining these devices, because if something is failing and there are hundreds and thousands of them across different places, and if something fails, it's sometimes, like for example, I would give you the example of wind turbines. So they are huge, and if some of the blades fail, it's very hard for anybody to go up and check what happened and to replace it. So then it becomes very important for us to know that have to know what can happen in the future, to predict it, that there might be a failure that might happen for in this particular wind turbine. So and then we can replace it, correct it, yeah. But mostly with this is big example, but with small devices it's hard. This is one of the biggest challenge right now, to how to manage them, how to
And the
maintain
power,
them.
and I would say that in a few years, another challenge that will be interesting is how we uh, replace and recycle them.
Yes, yes, that's true. Like we are already dealing with so much human created pollution around that we cannot recycle, and we should stop landfillings as well. But these are also going to create another level of pollution if not handled today, and we don't have the right solutions to handle the pollution that they will create.
Well, you
Yes,
can, but we could monitor landfills and pollution with IoT,
yes,
and then we'd
yes.
have to replace those devices and build
Yeah.
more devices to monitor the original. That's
Yeah, it's a vicious circle.
oh wow, that's an interesting thought. Like it's yeah,
Yeah.
it is it's extremely important to work at that too. So by the way, I think what really ties into the environmental discussion is that moving processing power from devices to the edge into the cloud actually helps you have smaller and cheaper devices, which are easier to
Yes.
recycle. Because
Yes, that's true.
if you went to the extreme of making your new thermostat an entire system, it will be the
Yeah.
size of a small fridge because you need
Yes.
everything in it, and it will
Everything
be
in
as
there.
yeah, and it will be as complicated to recycle as a full computer.
Yes.
Well, a thermostat is just few parts we can be really recycled easily. Yeah, that's
Yes.
super important. So that's another reason why learning. So yeah, last question.
That's why many it's important to keep it simple, and rather than having very complicated devices there that makes the life difficult later on. So that's why the first way is to have, that's why people are depending more on the platforms, the cloud or the on-prem, to deal with all the processing and not to go edge all the time. And then there's always the problems of different problems of connectivity, if they were not getting if the processing that you need to finally actually bring to the cloud, it's working or not, if they actually were performing fine or not. So there are another level of challenges that brings up. But in some cases you cannot avoid having the edge power. You need to have the edge devices to perform some computation. So it's it's important, that's why, to have the right edge analytics as well.
Oh yeah, definitely. The so last question, more closer to what you've been doing at the lower, at the closer to the metal. How would you describe a well designed cloud architecture supporting an IoT backend? What's your favorite tools? Docker, Kubernetes. Do you think containers are useful? Are you running something else? I'm very
Indeed.
curious.
Yes, indeed. Containers is like so much good, so much better, and have simplified the lives. So what I do currently is that I'm running, for example, any processing solution. So in my case, it's the SAS Event Stream Processing that I'm using. So it is a container-based solution, and it runs in with Kubernetes. Kubernetes actually provide, it's an orchestration for these containers.
Yeah.
So if something fails, it automatically comes up, and you do not have to really worry about that, that you need to restart this container or not. So there are many capabilities that why one should use Kubernetes when you have the containers, lots of containers. So here with the ESP, that's the event stream processing, if you
Mhm.
have here, either you, there are different architectures where the data from many devices is flowing into one ESP container, or there is a possibility that each edge has sending their data to their individual event stream processing container. So based on how the use case goes, um, it's um, it's important we have one container per ESP process, ESP per ESP.
Process. Yeah.
Yeah. So
The That yeah, that's been super important. The other thing I would like to single out is isolation. When you're
mhm,
running that kind of high throughput processing, I've done my share of high throughut processing in other fields in telephony. And when you're
yeah.
doing that kind of throughput, if you're not running in containers, one process can kill your entire
Yeah.
stack.
That's true. That's true. That's true. One, and it becomes very bulky on one particular uh, engine to run so many, to run so much workload and also give you the right throughput. And if it fails, it just brings down everything.
It
So
fails
that's,
horribly in general. Yeah,
yeah, and that's how primitive or traditional way of doing things. You have one engine that runs everything, but with containerization, you can distribute it in different containers and achieve the throughput and even higher throughput what you need based on how you're distributing your workload across them.
that's awesome. Great. So go learn about IoT, guys. It's super interesting. There's a lot to do, a lot to learn here. And thank you, Divya, for being with us today. There was
Thanks, Lucas. It
so
was
much
a very
information.
good conversation with you. I really enjoyed it.
Oh, thank you so
Yeah, and
much.
I didn't felt I didn't feel that 40 minutes have passed.
Yeah, it was super fun and super interesting, and we try to keep it on topics that people can follow for the most part. So if you have any other questions, is there's anything in particular you're interested with, I'm sure Divya can help you, and
Definitely.
reach out to
Yeah.
her, and she'd be happy to work help you figure out what's the best solution
Yeah,
SAS
you
will
can
give you.
connect me on LinkedIn, or you can just watch my different um videos that I keep posting on YouTube or and speaking at different conferences. You can watch them. There's plenty, and I'm part of this IoT community, and this is the world's largest IoT community. And there we have a lot of IoT practitioners and people from different companies. And they are from from businesses, and they are also from public and government sectors. So it's a very good community, and there you can get to learn a lot. We have often every week we kind of have different topics where people are talking about and sharing their knowledge and information, and it is for everybody, not just for people working in IoT related area, but also for small companies, big companies, for everybody. So it's all knowledge sharing, a very good platform for everybody whosoever wants to learn IoT.
Well, that's super awesome. Cool. So, again, thanks, Divya, for joining us today. Divya Gupta, a solutions architect, a senior solutions architect at SAS Global IoT Division.
Thank you.
And it was a great chat. We'll went through the world of IoT in a breeze, really. And for everybody else, thank you for joining us today, and I'll see you next week. Goodbye.
Thank you. Bye bye.